Hello again. We have with us Dr. Deb Mukherji, Managing Director at Omega Seiki Mobility, India's fast-growing last-mile connectivity solutions provider. Having earned his master's in technology from IIT Delhi, Dr. Deb received his PhD from Jamia Millia Islamia. He uses a data-driven approach in working towards India's switch to electric. An advocate of Make in India, his guidance has been instrumental in the birth of Rage Plus and Rage Plus Frost, Omega Seiki's indigenously developed electric three-wheeler cargo vehicles. Dr. Deb will now present on he will address the question to EV or not to EV. Thanks for joining us here, Dr. Deb.
Thank you very much, Swalia. It's a pleasure being on this forum. And I would like to make a presentation on electric vehicles and the opportunities it presents for metal recycling industry. Is it okay? Can you see my screen?
Yeah, we can.
All right. As Swalia said that, the topic given is EV or not to to EV. See, electric vehicles started the automobile about more than 100 years ago. It is ironical that we are talking about it again after a century or so. It is like coming back a full circle. The mobility, which was fueled by the fossil fuels for over 100 years, seems to be coming to an end. And now we are having a transition again to the electric mobility. Electric mobility is extremely important in the context of environmental impact that the fossil fuel cause, and some of the irreparable damages that they have done for over a century to the environment. In that context, I think electric vehicles are the future. They are one of the most talked about topics in the automotive industry. It is certainly the most significant change that we will see, and it will certainly have a very profound impact on this industry. So I would say certainly it is EV. Let's see how the electric vehicles are changing the automobile landscape. As you see, starting from 2017 to 2025, in about 8 years, the industry will reach to a level of roughly about 10 million units. And the penetration we would see is something around 12%. Well, this is still slow. And after that, we will till 2030, the complete the penetration of electric vehicles is expected to be even more than 50%. Deloitte study shows that 76% of the cars made in 2040, 76% of cars made in 2040 would be electric. So if we take an average of roughly about 80 million cars, those are made annually globally, we're going to have something like 60 million cars running on electric batteries. And China and Europe are expected to dominate this transition. Earlier it was China. China certainly has a head start, starting electric revolution somewhere around early 2000. And now Europe seems to be catching up, particularly after the pandemic. We do see a huge push from the European countries. So coming to the market estimates, market forecast global passenger PEV, the passenger electric vehicles, from 2.9 million units to 9.5 million units in 2025. In 2020, Europe overtook China as the largest contributor to PEV vehicles sales growth to become the largest PEV market. And let's see how US is doing. US passenger electric vehicle sales will increase from 280,000 vehicles to 1.05 million. So approximately 300% increase in 5 years until 2025, led by 12 states that have adopted the zero emission electric vehicles program. And after President Joe Biden has taken over, he promised during his election that USA would reach carbon neutrality by 2035. So this is expected to give a big push towards the electrification, with all the government fleet to be replaced by electric vehicles, and investment of in the electric charging stations of more than 500,000 charging stations would be done by the government. Now let's come to the context of India. India is the fourth largest automobile market in the world. We are behind now China, USA, Japan, and Germany. Now these electric vehicles are coming to India in a big way, and they're going to replace more and more IC engine vehicles in next 10 to 20 years. There are government mandates to the automobile industry to replace the vehicles by electric. We expect the electric volume for India by 2030 to be, as you can see in the chart at the right hand side, 80% of the scooters would be converted to electric. And mind you, India is the largest scooter manufacturing country in the world. Today, manufacturing roughly about 20 million scooters in a year. 30% of passenger cars, 40% of buses, 70% shared taxis, and 80% three-wheelers would be running on electric batteries. So this is quite a significant volume which will be converted into electric vehicles. Now, let's see how this is being fueled by battery manufacturing, which is a most important part, going into electrification. There are already more than 100 gigafactories in the pipeline for construction globally. So huge amount of investments are going into setting up of gigafactories to manufacture batteries of various chemistries, lithium ion being the foremost. 2030, lithium ion battery capacity will be up 7 times from 2020. So in 10 years, the industry capacity would have grown 7 times. As you can see here, Asia Pacific, which is led by China and Korea, would be having a capacity of 1625 gigawatts, roughly about 57% of the complete global capacity, up from 370. So that's almost 5 times. And globally, we will see a capacity jump from 475 gigawatt hours to roughly about 3000 gigawatt hours, roughly 6 times. Now coming to the metals and materials that go into manufacturing of these lithium ion batteries, lithium, cobalt, and manganese are the 3 vital elements, vital metals for lithium ion batteries. They are also highly energy intensive and environmentally impacting industries. The picture shows it all. Lithium is the most crucial metal, though not considered a rare metal. Lithium, around 52% of known global reserves are centered around Argentina, Bolivia, and Chile. These are called ABC, the ABC triangle, lithium triangle. And the mining happens majorly by companies from China, USA, Canada, and Australia. The lithium triangle is creating a war on water, causing tensions, and a recent drought in Chile has intensified it. So water is under tremendous pressure due to the lithium, because the brine solution where lithium is found has to be extracted out of water. Now, cobalt is certainly one of the dirty currencies, as you can see here over the timeline, how the prices have fluctuated. Now, cobalt prices fluctuated from 30,000 per ton going into 50,000 per ton in just 2 years. So 75% of cobalt was produced in politically volatile DRC, Congo, with questionable processes, meaning unethical mining, use of child labor, and unhygienic, unsafe mining, etc. So this is a problem. Coming to manganese, global manganese production is roughly about 18.5 million tons annually. It is mainly focused in South Africa, which has around 78% of reserves, China and Australia. Now, increasing demand from lithium-ion batteries is certain to increase the demand of magnesium, and only 2% producers are producing the manganese carbonate. This is important. The manganese carbonate is necessary for production of high-purity manganese. So, what we see is that due to this sudden jump in the battery demand, manganese is going to be in shortage. Nickel is a fairly stable metal, and the industry is also fairly consolidated, with the world's 10 largest producer accounting for over 60% of the global output. Now, coming to the battery recycling, as we see, almost 3,000 gigawatt hour of batteries would be in circulation by 2030. And after about 10 or 20 years, these batteries will come for recycling when their life ends for automobile. Now, this is another important point here, is that after ending their life for the automobile, they also have a second life where still almost 70% of the battery charge is available. The battery can hold charge up to 70%. This is certainly not suitable for automobile, but for other stationary uses like inverters, UPS, and generators, etc. However, the battery extraction, the material extraction from the battery is very complex due to the construction of the battery, lithium ion. It is made up of cells. The cells are made of cathode, anode, and electrolyte and separators. Now, these are very tightly attached to each other, sometimes using a very complex gluing system, so that the battery is durable and it does not deteriorate, etc. So taking out the metals out of this kind of construction is extremely complex. However, there are various government policies and push which is mandating the recycling of these metals. And it is expected by 2035, over a fifth of lithium and 65% of cobalt would be obtained by recycling. This is fairly significant. The recycling rate which are required under a new law proposed by European Commission is very important. It will significantly reduce EV's demand for new material. So these are the various attempts by government and initiatives by government and other groups leading to recycling of batteries. Now, vehicle recycling is an opportunity to reclaim various metals. Now, automobile is a very complex system in having metals, non-metal, then there are rubber, plastic, and various other alloys and systems. Now, this has to be taken out, dismantled, and then metals have to be crushed and fed back into the foundries for recycling. Almost 95% of steel and aluminum is recycled, is reobtained. So instead of focusing on recycling, I think we have to call it a reclaiming industry, and we have to employ various technologies which are available to reclaim. Now, this is a very major opportunity. This is an economic opportunity of $500 billion for recycling globally. Social opportunity to generate high-skilled jobs. Recycling of battery is an extremely important opportunity for entrepreneurs. Technological opportunity to design and develop highly efficient and IoT-enabled smart vehicles, smart batteries, and highly efficient electrical systems. And obviously, these impact environment in a very positive way. Just to summarize, I would say electric vehicles would be a game changer for the automotive industry globally. By 2040, as I said, 76% of global car production would have shifted to electric. Electric vehicle is a great opportunity in next decades to create a sustainable circular industry so that we have carbon neutral industry from cradle to grave. EVs produce less emission over lifetime as compared to IC engines. They do not have the direct tailpipe emissions, thereby reducing carbon and NOx in the air, which are very harmful. In the end, I would say for an activity to be sustainable, it must be economically attractive and environmentally friendly. It has a positive impact on environment, safety, and clean living of a large population. A sustainable operation is a target we need to attain as the world faces material shortages, increased costs, and more stringent environmental regulations. The economic spillover of recycling and reclaiming and using electrical vehicles are going to be immense. So in the end, I would say where I started, it is certainly EV now, and we do see a very healthy and clean environment caused by EVs. Pollution is a problem, and I think electric vehicle is the solution. Thank you very much. Is there any questions, Swaliha?
Yeah, Dr. Dev, yes, there's one question here.
Yeah.
Thank you very much for that insightful presentation. So there's a question here from Arwa asking you, like, how do you see the effect of electric cars on waste tires generation?
Sorry, I didn't get the question.
How do you see the effect of electric cars on waste tires generation?
Waste tire?
Is that? Yeah.
Waste material generation.
Tires. End of life tires, yeah.
End of life tires. Okay. You see, the tire recycling has been there. The tires are basically same in terms of technology for EV and non-EV, the IC engine vehicles. The tires, the process of producing the tires is same, and the basic technology is also same. Only thing, electric vehicles are starting to use less friction tires and similar quality tires. So the essentially the recycling of tires would remain same, and all the materials that can be taken out, reclaimed, like the steel wires and other metals, could be taken out, and then the tires can be sent for reclaiming to the tire manufacturers. So essentially, there is no difference between an EV and non-EV recycling of tires. No, you're on mute. You're on mute.
Thank you so much for joining us here, Dr. Deb, and for sharing your insights. And if there are any further questions coming in, we will pass them on to you so you can answer them later.
My pleasure, Swalia. Thank you very much. And I appreciate you giving me the opportunity. Thank you. Bye-bye.